Hello, welcome to the second part of our first lesson in our unit of graphing quadratics in our grade 10 academic math class. So this is the second part. First part was introduction to some of the terminology that we're going to be using and being able to identify some of the key features of a quadratic like the vertex, the direction of opening, the axis of symmetry, and whether or not our parabola is going to model a maximum or a minimum value. So now we're going to talk about graphing. Now if you think about the pre-lesson, we were working tables of values, and that will absolutely always work. You can always use a table of value if you're not sure how to go about graphing a quadratic. I will say though that there's a fair amount of work in using a table of values to graph something, and there is a faster method. And the method that we're going to look at when we're talking about graphing quadratics in vertex form is listed here. These are the steps for doing it. Now, the part that I'm talking about specifically is right here, where we talk about sort of the patterning that's going to happen here. Now, this might be best illustrated with sort of just a little space down here. So you don't have to copy this down. I'm just going to talk our way through it. So what I wanted to point out was when we dealt with y equals x squared, and we were making our tables of values, what we noticed is that when we put in, I'll just make that sort of table here again a little bit, that when we put in a 3, a positive or a negative 3, it was spitting out values of 9. And when we put in either a positive or a negative 2, it was spitting out values of 4. A positive or negative 1 was spitting out a 1, and 0 spits out a 0. So what we can do from the vertex, whatever the vertex of our parabola happens to be, essentially this pattern that we've observed as we've been graphing is from our vertex, if we go out 1 unit, either positive or negative, we're going to go up that same amount squared. So in this case, if we go out 1, we go up 1 squared, which is going to be 1. If we go out from the vertex 2 units. So let me change up my color here a little bit. If from our vertex we go out 2 units in either direction, we go up that same amount squared, which becomes 4. So from our vertex we go out 2 and up. Well, that is terrible. Up 4. Out 2 and up 4. And for the blue ones, it was out 1 and up 1. Out 1, up 1, and if from our vertex we go out 3 units, so that's 1, 2, and 3 units, we go up that same amount squared, which will take us somewhere up in this neighborhood, probably a little higher actually. If we go out from our vertex 3, we go up that same amount squared, which is going to be 9. So the reason I want you to remember this is because from our vertex, and that's why I keep saying from the vertex, from the vertex, from the vertex, no matter where our vertex resides, if we go out 1 in either direction, we go up 1 squared. If we go out 2 in either direction, we go up 2 squared, which is 4. And if we go out 3 in either direction, we're going to go up 3 squared, which is 9. So in theory, all we need to know is where our vertex is. And from then, we from the vertex go out 1 and up 1 squared, out 2, up 2 squared, out 3, up 3 squared, from wherever our vertex is. So let's try to utilize that. Here we have a quadratic relation in vertex form. Y equals x plus 3 in brackets, all squared minus 5. So let's state the vertex first. The vertex is going to be, and remember, it's the opposite of how it appears in there. This is actually x minus 3 that we're seeing. So our vertex then is going to be negative 3, negative 5. Our direction of opening, well, our a value here is going to be plus 1. It's invisible, but it's there. So our parabola is going to open up. When parabolas open up, they have minimum values, as we will see once we're done graphing. And the equation of the axis of symmetry is x equals h, and the h in this case is negative 3. So first things first, let's plot the vertex on this graph. So that's negative 3, 1, 2, 3, negative 5, that's down here. All right, so there is our vertex. Now, as I was saying, from our vertex, we know that our parabola is going to be opening up. And based on the plot pattern of quadratics, we know that we can go out 1 and then up 1 squared. And we're going to do that in both directions, out 1, up 1 squared. There we go. And now let's go back to our vertex, and from our vertex, out 2, 1, 2, and up 2 squared, which is 4. 1, 2, 3, and there's 4. Same thing on the other side. And from our vertex, we are going to go out 3, so 1, 2, 3, and up 3 squared, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And again, the mirror on the other side. So there is, never mind all the dots I put in, there's our parabola. We didn't need to do any additional table of value work. We used what we knew about the plot pattern, and then we put our vertex on and plotted appropriately. So I'm going to use my eraser just to sort of clean up some of the dots here a little bit, but that is certainly the gist of how you can graph a quadratic without having to use a table of values if you know the vertex. So as before, we are going to sketch our line in a curved way through our points. We're going to get some arrows up on top, and we are going to label our equation. So our equation was y equals x plus 3 all squared minus 5. And I'm going to label, now again, we could label our x-intercepts, but we don't actually know what they are. They're kind of falling in between two integers, so we're not going to label those, but we can label our y-intercept because it's nice and just sitting there on an even integer. So there it is. The last thing we want to add in here is our axis of symmetry. So I'm going to draw a dotted line all the way from the bottom through the vertex to the top, almost there. And now I'm going to label that with the x component of my vertex. And as we know, the x component of the vertex is -3. Last but not least, I want to label my vertex itself. The vertex is down here, and it is point -3, -5. So this is a beautifully labeled quadratic. We have on there not just the vertex labeled, the y-intercept labeled, the equation labeled, and the axis of symmetry labeled. We also have the dots drawn in the right pattern. So this is how you graph a quadratic given vertex form. Now, we're going to do one more example of this. Let's work through it. So we have here the graph, or the quadratic relation y equals negative bracket x minus 2 all squared plus 6. So let's find our vertex first. Recall that our vertex is sort of the opposite of how it appears here. This is actually x minus +2 all squared. So our vertex then will be +2 and +6. Our direction of opening is based on our a value. So the a value out front here is a negative invisible one. So that means that our parabola is going to be opening down. Parabolas that open down have maximum values, which we'll see when we get to the graphing. And the equation of the axis of the symmetry is x equals h, which in this question is going to be 2. So let's start by putting our vertex on there. So we have 2, 6. There's 2, 6. Now again, we're going to use the plot pattern to graph here. So our plot pattern, from our vertex, we go out 1, and this time we go down 1 squared, which is 1. Out 1, down 1 squared, which is 1. Back to the vertex, out 2, down 2 squared, which is 4. 1, 2, 3, 4. And the same thing on the other side. Then back to the vertex, out 3, 1, 2, 3, and down 3 squared, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9 is right here. And the same thing, out 3 in the other direction, and down 9, which takes us to here. So again, we have a beautifully plotted parabola. I'm just going to clean up some of the dots I put on there. And it just now needs to be drawn in and labeled. So let's try that. I'm going to draw it in with a curvy line as best I can. There's our curvy line. Let's get some arrows on this thing. And let's get some labels on this. So again, our x-intercepts, they don't go through even integers. They kind of go part way between them, and we don't know where it is, so let's just leave that off. We do have a nice y-intercept, however, at 0, 2. We can label the equation itself, and that is going to be y equals negative bracket x minus 2 all squared plus 6, I think was what we had there. Yep, awesome. And let's label our vertex. Our vertex is going to be 2, 6. And lastly, dotting on the axis of symmetry. Again, all the way from the top through the vertex to the bottom, and labeling it x equals h, which in this case, x will be equal to 2. And there is our beautifully graphed quadratic in vertex form. So this is a lot to be learning right now. We're going to throw yet one more huge idea on you in part 3. So again, just make sure you've kind of got this under control. Maybe rewatch it if you're not 100% sure. And then we'll see you in part 3 to finish up this monstrous first lesson.